Hello everyone, welcome to the video of Big Data and Hadoop. This video is actually brought to you by Analytics Finishing School. Let's get cracking. Big data, I guess this term is sort of known to all of us living in the 21st century, given most of our time is actually spent in browsing and updating our Facebook status, Twitter account, LinkedIn profiles, and WhatsApp. Can't really imagine a world without these social media, huh? Pretty much. Having said that, given we are sort of basing our lifestyles and then each one of us is actually connected to internet, we're producing a lot of content every day. So every year, every day, there's been a sudden tremendous increment in the digital content for us, and that's why it's just sort of necessary to term this huge amount of data as big data. So big data is nothing but large amount of data which is generated from different social media, from different places, from companies, database, from connections to the internet nodes that are producing a lot of content throughout the globe. Okay, so big data is nothing but huge amount of data sets. Okay. There's been a beautiful quote by one of my favorite author, who's actually described the immensity of big data as big data. Without big data analysis, companies are blind and deaf, wandering out onto the web like deer on a freeway. So it's one of the beautiful quote I recall whenever I feel like talking about big data, which was told by Jeffrey Murray. So it is true, right? If you have anyway so much of information, you can utilize and harness it for your necessity and maybe make smarter predictions, right? So that is the intention why we should be actually taking courses such as big data analytics. Why should we be even studying such kind of courses in the first place, right? Okay, so first of all, I've given you an explanation about what exactly big data is and why do we need to sort of study this kind of new data set generation and then go about doing the analytics on it. The most important question still remains unanswered, and that is actually the need of big data in the first place. I mean, we talk about there's a lot of information, there's everything, but why have we sort of started emerging into NoSQL databases than are typically traditional RDBMS, right? For people who are not sure what RDBMS stands for, that stands for Relational Database Management Systems. This is nothing but the table, rows, column structures we might have studied way back in our engineering colleges or probably in our 11th and 12th if you would have been studying C++, or if you've taken any certifications with Oracle, okay? So basically, when you have a lot of large data sets, it sort of becomes really tedious to put this information in RDBMS. Why exactly this is tedious? As I said, this is an introductory video. I would not like to get into the technicalities of why this is happening. We just would like to throw upon a light of question, and then I'd probably hope to see my dear audiences in our classes wherein I'll be explaining why this is happening, okay? So large data sets are sort of very difficult to be fit in RDBMS, which is Relational Database Management Systems. A few examples of RDBMS includes SQL Server 2005-8, MySQL, okay? Why? First important reason, it's the storage cost, then search performance, and then analytics and visualizations. Storage cost, I will again not get into the technicalities at this point of time. Search and performance, yes, definitely. As I've just said that big data is large amount of data set, it becomes typically unpractical to sort of query the complete set of information through the rows by just iterating a query set, correct? This might sound at this point really a haphazard definition, but again guys, I really promise you in this course you will understand why exactly there are failures of RDBMS with big data. I'll actually get into an in-depth algorithmic details as to why things are happening this way, okay? Definitely for analytics and visualizations. When we say analytics, we're trying to invoke functions from stat packages, from some of the most trigonometric function series and other sections, right? And when we do that, it sort of adds computation to our hardware with respect to the operations we're trying to perform through those functions, right? So overall, in very simple language, if I was supposed to say, RDBMS do add computational complexities to large data sets. That's why we need a sort of better migration strategy for this, okay? What is the better strategy? The better strategy is actually to use parallel processing of hundreds of machines, right? So if you're supposed to have terabytes and petabytes and gigabytes, so let's say we have a large amount of information and that information needs to be computed on probably one system, or let's say one device. If we do that, and let assume that the system actually has an upgraded configurations of its hardware and software support on the latest Intel processor. Still, with that operations operating gigabytes and petabytes of information at a processing speed of seconds is unpractical, right? Because by far, none of the algorithmic structures are parallelized into such way that they can adverse into the effects of so many complexities of the users or datasets per pixelated information, correct? So to address this problem, we can probably combine together, let's say, thousands of computers and let them all perform some part or subsections of the bigger operation. That way, we are actually dividing the computational time between the n number of computers that we are arranging through, correct? Again, if this is all something which is not very clear and distributed programming has not been a part of your course, it is okay, because we are going to be discussing distributed programming paradigms and principles in detail again in this course. So I just want to give an idea in a very simple language why in the first place we need to move from RDBMS to parallel-based distributed computing systems and where exactly Hadoop comes into picture, okay? So up until now, what I was trying to say, if I was supposed to summarize, we have large sets of data which cannot be sort of inputted in RDBMS because of being less efficient with respect to storage and complexity. So the best way to do it is actually doing parallel processing, which is also called as distributed computation on multiple machines, okay? There comes Hadoop for us, okay? Apache Hadoop, what does it do? We'll just see it. Apache Hadoop is an open source software framework used for distributed storage and processing of very large data sets, okay? In my previous slide, I just explained that since we have large data sets and one system might not be capable of performing the operations on that many large data sets, we can actually take multiple systems. Having taken multiple systems, we can allocate specific functions to each system so that the final output is sort of really fast, given in parallel systems will be working together. So Hadoop helps us do that. So if I would supposed to reiterate on the definition, it says Apache Hadoop is an open source software framework used for distributed storage and processing of very large data sets, okay? So it's processing the data which has been given to it on different parallel systems, okay? The core of Apache Hadoop consists of a storage part known as Hadoop Distribution File System, HDFS, and a processing part called MapReduce. So the part which stores the information is called as HDFS, which stands for Hadoop Distribution File System. And the part which does the processing is a very generic term and I will not get into the details at this point of time. But the part which does its processing is called as MapReduce, okay? The base Apache Hadoop framework is composed of the following modules. Hadoop Common. It contains libraries and utilities needed by other Hadoop modules. Hadoop Distributed File System, HDFS, a distributed file system that stores data on commodity machines, providing very high aggregate bandwidth across the cluster. These are just some of the terminologies that it's okay to know at this point, and it's totally okay if it's not clear at this point, because the whole point of having the course in the first place is to understand these components really well. And in an introductory video, it becomes unrealistic on my part to actually explain all of this in detail, okay? But just to summarize these 2 points in very simple terms. Hadoop Common is a section wherein you can see all the libraries and utilities which comprises of the Hadoop module. And HDFS is the file system which is sort of storing storing the information in a form of clusters, and it's sort of aggregated on bandwidth, so it's providing a very high processing time speed. Okay. Hadoop Yarn, a resource management platform responsible for managing computing resources in cluster and using them for scheduling of users and applications. The last point I just mentioned, that there can be multiple clusters or group of systems actually performing an operation. Hadoop Yarn is actually a resource management platform that sort of manages the execution of operations between these clusters. Okay. Hadoop MapReduce, it's an implementation of the MapReduce programming model for large-scale data processing. I'm going to be getting into the detail of Hadoop MapReduce in our course a lot, because this is the essence and crux of a lot of important source ranking algorithms as well. And it's also the base and foundation of some of the most basic artificial intelligence based algorithms too. So this is something that will be discussed in very detail in our course series. Course overview. Let's see what can we be expecting from this course. So the first thing that we can sort of expect from the course is the introduction to big data. Moving forward, we will be discussing the big data platform. In this, we intend to discuss stuffs with problems with traditional large base scale systems. We're also going to see the overview of high value big data use cases and other sections. We are then going to see the need of Hadoop, what is Hadoop and why was it sort of required in the first place. We are also going to be understanding big data solutions, how does it work in cloud, and where does Hadoop comes into the picture. Then we are going to be discussing Hadoop's architecture, Hadoop Administration, and we are also going to be discussing Hadoop Components. Okay. The next section we will be discussing will be MapReduce and Yarn. As I've said, MapReduce in itself is a very important algorithm and forms the foundation of a lot of search ranking algorithms for some of the giant search engines, including Google and Baidu, B-A-I-D, that's supposed to be a Chinese word. I am not good with the Chinese part, so I'll just leave it to your preferred pronunciation there. Okay. Having said that, we are also going to be expecting how can we be importing information and data sets into Hadoop. We are going to see how we can use Sqoop using Flume, accessing Hadoop data using Hive, Hive DLL, Hive DML, Hive operators and functions, Hive storage formats, and BIG. Okay. So again, at this point, it's totally okay if these terminologies are not something that you have heard before. I've sort of repeatedly said these things over and over again just to make everyone confident enough that it's okay if you don't have backgrounds with mathematics, statistics, or basic computer programming, because as we go through the course series and we brush up our knowledge, we're going to touch upon some of the important concepts that we might be needing anyways, so it's totally fine. Other sections we will be discussing in our course include HBASE, Zookeeper, Spark, introduction to Spark. Definitely guys, I must just hold on here a while and say Spark is something which has a lot of job openings coming across, and it's really an emerging technology that should really be considered one of a high booming sector for another 3 to 4 years. Then we have Spark application programming, introduction to Spark libraries, Spark configuration, monitoring and tuning. In general, we cover the complete Spark as well, along with Hadoop. And there's the final case study, which is again going to be totally related to a company project per se. You get a total live exposure and you will understand how can you sort of use the knowledge that you've just learned here and put it into a real world practical business implication. There'll be also other useful sections for this course as well. And we're again going to help you think like a big data scientist here, help you with your interviews, help you build products which can generate revenue for you, connect you with smart people who are sort of excelling in this domain, and also help you build your portfolio. I hope you enjoy this course series, and I really do look forward for everyone to attend the course. Thank you.